So yesterday we briefly discussed about this lambda function. We have also discussed about this global and non-local keywords and where they are actually applicable. So the three other keywords that we haven't discussed earlier is this yield, assert, and pass. So let's try to write some code that will help you to understand this keyword, the use of these keywords. So first of all, let's start with yield. So yield is used inside a function like return statement. So let's write some codes regarding that. Okay. So let's define a function, say squares. So it is, for example, it is not taking any parameter, and it is, so for example, it is taking one parameter, say n, and it is returning the square of n. For example, this is just for the example we are using this. So if I now call squares with some value, say 4, it will be providing us with the value of 16. Now what if we want to have the squares of say all the numbers between say 10 to 20? So for doing that, what we need to do is we need to write a loop like for I in range from 10 to 21, and then we'll need to call this with I, and we need to print the corresponding statement, right? Yield can be used to do something similar pretty easily. So let's define the same function squares in a different way. So let's define the same function squares with, so for example, I am putting this for loop inside. I mean, this is just for the sake of example, just for the sake of this discussion. This is a very naive example. So for I in, I am doing the same thing, range 10 to 21. And now, if I return, can someone say what will be the output of this? Say I. So if I execute this, so now if I call this, what will be the output? Can someone say? Anyone? So I'm calling this function, and there is a for loop which is containing one return statement inside it. So what will be the output of this if I execute this? Please guess, at least guess.
Sir, 10 different squares, like 10 to 21.
I mean, this same output, right?
Yes, sir.
The same output is supposed to be, but when this return statement will execute, the return statement will return the flow from here to here, isn't
Sir,
it?
the last one only.
So basically, for I, so for different values of I am squaring the number and I am returning. So once one return statement executes, there will be, the flow of execution will be coming back to the calling place. So if I just execute it, it will be returning only the first value, because for I equals to 10, it is returning the value from here to here. And there is no scope of getting the value to 11. Is it clear? So to do that, what we will be doing is we will be using this yield statement. So now if I execute this, you will be able to see, sorry.
Sir,
Now, yes.
sir, like I observed that if we don't write print over here, I mean in your Jupyter notebook, it works
Mhm.
perfectly. But when we have to do it, then without print, sometimes result doesn't come.
Yeah, for example, here.
No, no. In
So,
your case, I was trying in that online one.
mhm.
There, I need to
No, so
give the print
basically,
statement,
yeah, I got it. So
but you're not giving it's coming. That's why.
let's define a equals to 10, and then just if I put A here and execute it, it will be giving us the output. I mean, this is
So it
same,
works
but
like
there
the
is one.
shell.
Sorry, this is a
It works
different
like the
shell.
Python shell, that one.
Exactly.
Okay.
So yeah, there is a difference between this only A and print A. Can someone say what is the difference? So if I execute this, you can see there is no out statement here. But if I have this, you will see there is a one out statement here. So that is basically the output, direct output, and the print is basically the, I mean, that is also the output, but this out statement is not there for a direct output, I mean, direct print statement. I hope it's kind of clear. So is it clear, Devdatta? So it is the
Yes,
beauty of
sir.
this Python's this
Yes,
cell
yes.
in this Python notebook, IPython notebook.
Yes, yes.
All right. So now what I am doing is, so I have, instead of putting return, I have put yield. Now I am calling this same square function, and I am taking this. I am considering the output to be put in a variable, say s. And now if I execute this, you can see it is executed, but there is no output. Now what I can do is I mean, basically the whole output is stored here in s. So if I do this, sorry, extremely sorry, it should be I. Oops, oops. Okay, so let me execute this, then this, and then this. Okay, so you can see. So basically, this yield is returning every single output here into a sequence data type here in this S. So if you try to check the type of S, you will see it is a generator. It is a kind of, again, some sequence data type, not actually it is a data type, but it is a generator that is containing all the individual values. So as we have seen earlier, if it is returned, it will be returning the first statement, the first value, and then the rest of the execution of this for loop will not take place. But if we have this yield, it will be return the individual values into a generator, which is kind of a sequence data type, not actually data type, but it is like a data type, like list, which can be, we can use kind of a for loop, kind of a loop to traverse the individual items there in this generator. Any question? So this is the use of yield, and that this is the difference between using yield and return. So as you can see, I mean, there are situations, I mean, we can kind of avoid using this yield by redesigning our code, but it is the use. I mean, we can write the code in this way as well.
So we do not need return when we use yield then.
No, there is no return. So in case of return, the return was returning only one value at a time. I mean, we can return multiple values as well, but here for individual output, I was unable to return the individual outputs from this function. But using this yield, I can do that. So you can see the individuals for I equals to 10, it is returning 100, and then for I equals to 11, it is again returning 121, and so on. But if we use return here, only the 100 will be returned from here, and the rest of the loops will not get executed. I hope it is clear, right? Any question? All right. So another keyword is assert. Assert is again something that is used mostly for debugging purposes. So this is the keyword. So yes, so this is the keyword that is called assert. So how to do that? It is used to check some conditions. So for example, I have initialized some variable I equals to say 10, and if I use this assert here, and an assert statement should be containing this assert keyword, then some condition. So for example, I want to check whether the value of A is, say, less than 50 or not. So I just need to put this, and it will be, I mean, I can straightforward execute this. So if this statement is not true, it will be returning us some exceptions. So let's try to do that. If, so for example, so let's have it this way. So now I am initializing again the same variable with 100. Now I am checking whether the value of a is less than 50 or not. Now if I execute this, you can see an exception is occurring, that is called assertion error. So you might be wondering what will be the application of this statement, this assert statement. So for example, let's define one say one list, say vowel, containing all the vowels in English so the vowel, this list should be the length of this list should be what, 5, right? Now we can check. So assert the length of this vowel list should be equals to 5. Now if I execute this, you can see there is no immediate output. So basically, as this statement is true, there is no assertion error. Now for example, if I put another item here, and now if I execute this, sorry, I forgot to execute this one. Now if I execute this, you can see there is this exception is occurring, which is this assertion error. So the application again is to debug your code. So for example, you are expecting one list to contain say 100 items, right? So in between, so if you want to check whether there are 100 items or not, of course you can use, as I stated earlier, there are ways of avoiding the use of this as well. You can also use this if statement as well. If length of this list is not equals to 5, then print error, something like that. Now if I execute this, so if anything is initialized with something beyond 5, it will be giving us this error statement. Oops, sorry. So again, using this assertion, we can do the same thing. But as you have seen that we can kind of avoid using this assertion using some kind of if statement as well. It is true. Any question regarding this yield and assertion, assert keyword?
Sir, can assert be used in a conditional statement?
No, no. So we were mentioning that if assert this kind of thing, right?
Yes, sir. Yes, sir.
So can someone guess what will be the output of this? If assert length equals to true, then say print, say hi, say okay. Can someone guess what will be the output of this? I mean, you can guess. Any blind guess.
Assert returns nothing, so
Assert
nothing will be
returns
out.
nothing. So if nothing, right?
Yes,
Then print okay. So if I execute this, what will be the output?
nothing will be printed.
No. So it is an invalid syntax. So if nothing is not defined, so it is equivalent to, sorry, it is equivalent to using this if print, okay. So you can see the same output. So invalid syntax, because as it is not returning anything, it is just empty. So it is the same output. Got it?
Yes, sir.
All right, so let's move ahead. Yeah, so keywords are, as we have discussed, keywords are case sensitive. So every keyword, most of the keywords are with all smalls, but some of the keywords like this false, true, none are starting with a capital letter, and then the rest of them are false, small letters. Then we have discussed about identifiers and variables. Identifiers are the name for
That,
assigned. Yes.
sir, you have not said about pass.
Yeah. So yeah, we will be discussing pass. I mean, yeah, I have that in mind. So regarding, I mean, while discussing, recapping about this break and continue, I'll be discussing about pass. Don't worry. Okay, so identifiers are the names given to variables, functions, and classes. We have discussed about variables, we have discussed about functions, as well as we have discussed about classes. So these are defined by Python programmers. And variables are we specifically highlighted on variables because that is the mostly used identifiers in any programming. So, we have learned how to assign some values to a variable. There are certain data types of different variables as well. Like these are the numerical variables like int, float, and complex. Complex was I forgot to put it here. So in int, float, and complex were the numerical data types. This is a string data type. This is a Boolean data type, and we have also talked about list, tuples, sets, and dictionary. There are certain rules on declaring, on naming an identifier. So I hope everyone remembers the rules. So although this is a part, completely part, this is a fine, you can use an identifier named like this, but this is actually a bad naming convention. So if you want to use multiple words, so the basic convention is either use this camel text, like you need to capitalize the words in between, like this, then I should be capital, is A should be capital, A, then valid V capital, and something like that, or you should use an underscore in between the individual words. So we had also talked about literals. So we had also talked about constants, Python expressions, which are very much, the base of any programming. We had also discussed about different operators and where they are applicable. We had specifically, elaborately discussed about Python statements. Basically, these kind of 4 kind of statements like assignment statement, conditional statements, some general statement, like here in this case, it is a print statement, and import statement. Sorry. And also, if we want to repeat some execution of some particular topics, we can use some kind of repeated statement, like using this while loop or for loop. So these are the this is the syntax for using a while loop, and this is the syntax of using a for loop. And these are some kind of special kind of loops. That is, this is an infinite loop. That is, this statement will continue printing almost practically theoretically forever. This conditional infinite loop is another special type of infinite loop, which is infinite unless some condition is met. And this is a nested loop where there is a loop inside a loop. So we had also discussed about where to use while loop and where to use for loop. So generally the concept is we should use, not we should, but most of the time we will be using while loop when we do not know the number of times the statement inside the loop will be executed. So we had also discussed about some loop control statements like break and continue. So in this example, this is a for loop. So here this break statement will bring the execution out of this for loop, outside this for loop. While this statement is, this condition is true. The same is true for this while loop, where when this condition is true, this break statement will get executed, and the execution flow will be coming outside the while loop, and the rest of the codes here or here, it will not be getting executed for that traversal. Continue is similar, but it will continue. So this portion, again, the codes just after this continue statement will not get executed. The after encountering this continue statement either in for or while, the loop will start execution for the next value, for the next iteration. There is another statement another loop controlling statement, that is called pass. So the pass is kind of similar to the simple flow of execution. but it is mostly used to fill out, I mean, it is mostly used to fill some voids. So for example, here I have written one for loop for I equals to for I in range 10, that is this loop will continue for 0 from 0 to 9, and if the value of I is even, it will pass. Pass means the execution will be skipped from here to here, so just outside this if loop and the corresponding else loop, of course. So as you can understand that this is the general flow. So if we do not put anything here, if we just put one print statement here, it will be the same thing, right? So let's try to write this, it will help you to understand this. So let's write, so for I in range, so let's print the event statement here as well. Else and say what are we checked, okay, print, and now print out. So if I execute this, so you can see even checked, odd checked. So basically if we print the value of I here as well, so for I equals to 0, it is basically it's not even, but as this condition is true, so it is, for this example, it is considered as even, then checked. So basically the flow is from here, then for I equals to 1, here, then here, and so on. So if I put a pass here, it will be the same, the output will be the same. So the pass will continue the statement from its general flow. So why what is the purpose of using this pass statement? Basically, if you want to, so if you want to do something here, say want to impose some, say some restriction, but you, I mean, you want to do that later. So if you want to do something later, then if you put only this statement, I mean, if you put only this if and this, it will be causing you some error, right? It is not a syntactically correct, I mean, thing to write. So although it is saying that indentation error, because this statement is expecting to be right shifted one place, but it is actually erroneous. So that's why if you want, if you have some conditions that you want to handle later while developing your code, so you need to use this pass. So pass will be, you can, I mean, the again the purpose of pass is, if you want to have some extra functionality that you want to add later, it is not immediately needed, but you want to add that later, you can use that condition and you can use just this pass statement. Any question?
Sir, if we want to handle that exception or any problem later, then why are we even checking it for now?
No. So for example, let's take an example like uh, say this say you want to make one website, one not website, but you want to make one web portal where people can register themselves, okay, and to register one needs to have a valid, one needs to have an email ID. Now for the time being, say for the initial for the initial uh, version of your portal, for example, you just write, you have, I mean, you just write that, I mean, you are just checking whether the email ID that he is providing is a valid email ID or not. Valid in the sense, valid syntactically or not, right? So if I just put this, so if say you are having this email in this email state variable, so if email, so if valid email, valid syntax means the syntactically it is correct. So you have defined one function, say valid syntax, which is considered taking an email, and it is returning either true or false. So for the example, let's, I mean, I'm not writing everything here. So it is only checking whether the syntax of the email ID is correct or not. So you are doing something, but inside, so you are writing, say for example, you are creating and else you are stating that wrong email syntax. Now in this statement you are only checking the validity of the syntax. So if someone had given some email ID like this, which is not actually theirs, so like this @gmail.com, I am pretty sure that this email ID is not present, right? So initially, for your initial launch of your web portal, you are only checking the validity syntax. So if you want to check the corresponding existence, so existence email existence check, then you and you want to check this, you are just putting a pass here. You get it?
Okay. Yes, yes, yes.
So you want to impose this, you want to have this functionality, you want to have this uh, extra checking later, not for the initial launch of your portal.
So that the next time I will not have to put all indentation blocks and everything.
Exactly. So you just need to put the things here, the corresponding checking and the corresponding things. You just need to put it here in this syntax, in this indentation.
Okay.
So that is the purpose of using of this pass. Any question?
The continue will also do the same thing, no?
No, not actually. Continue will be continuing the loop from the beginning. But as I stated in this example, pass is just, so if we put a continue here, can someone say what will be the output? It will not be the same. I mean, so print even. So you can see this is the output, and if I place a continue here, will the output be same? So continue will be continuing.
Right?
So only the events will be getting printed,
Yes,
because
not the checked.
I mean this checked will not be getting printed.
Yes, yes.
So if I just execute, so basically it will be 0 even, then 1 odd checked, then again 2 even, then 3 odd checked, because this continue will be guiding the execution from here to here. So if I just execute this, you can see 0 even, 1 odd checked, 2 even, 3 odd checked, 4 even, 5 odd checked, and so on. So it is not similar to use of it is not similar to use of continue.
Yes, sir, got it.
Is there any further question regarding this? So these are the keywords that were left to be discussed. So then we discussed about strings, and we discussed on how to traverse a string, how to initialize a string, and also how to apply certain operations like concatenation, like with plus or with star. We also applied this membership operator, that is in, to test some existence of a substring inside an existing string. We had also discussed about certain string functions, some built-in string functions there in this in Python. There are some certain string comparison operators which are also which are exactly similar to those of numerical comparison as well. But there is a difference between, the way the strings will be compared will be on the basis of this lexicographical order. So like in the numerical case, like 1 2 3 4 is the ascending order. uh, the similar thing in string is A B C D, that is the lexicographically ascending order. As a real life application, we had written kind of a very basic captcha generation and captcha, not comparison, not the whole thing, but a random captcha generation problem that we had written. We also discussed about what are comments, which is basically nothing but a certain type of strings. We discussed about single line comments as well as multi-line comments. We also discussed about the use of trimming some strings, like removing the extra spaces from the left using this L strip, from the right using this R strip, or from both sides using this strip. But there was a shortcoming that we have discussed, like in case of multiple spaces in between two words, these strips will not be able to remove them. So for doing that, we had actually written one code which is an advanced strip which can do that. I think we have written that in our assignment. Then we discussed about the compound data types like list, tuples, set, and dictionary. Regarding lists, we kind of almost discussed about creation of list, insertion item in a list, access items in an existing list, change items, delete items, searching item, copying item, and so on. And we also discussed about how to sort a list. There are two ways of doing that, using sort and using sorted. Both are inbuilt functions in Python. To insert, we had discussed about append, extend, insert functions. To remove, there are four ways, as we have discussed. There are four specific ways of removing items from an existing list. To search items or to reverse an item, there are these kind of functions are available. Then we discussed about set. Again, I'm just going through them. So the sets, we can also apply these mathematical operations there. Some built-in functions are also available in set. What are the advantages of set over list? We have discussed. In list, we search in, the search, if we want to use this in operator, this membership operator, to search for the existence of an item, it will be doing a linear search. That is, if there are say 1000 items and the item that you are searching is at the 900 position, it will be considered checking individually whether the first item is the searching item, then the second item, then the third item, and so on. It is basically called linear search. But in case of set, it will actually be doing something similar to a dictionary that we have discussed. So it will be straightforward checking the position, checking whether this 7 is actually present, the searching item is actually present in the set or not. There is no restriction, there is no provision of using this linear search here. So that's why searching in a set is very fast. Then we discussed about tuples. We also highlighted and differentiated between sets, lists, and tuples. And okay, so I think okay, then after that we discussed about dictionary as well. I think I put the dictionary. So after that, our classes were on function. That's why these functions are there. So functions is a way of grouping related statements together in a chunk of block of statements in a function. You can say again, it's a chunk of block of statements, you can say, that can be reused for later cases as well. And it can return a result value. It can be, not a result value, it can be a set of result values as well. There are certain built-in functions for that we have used throughout, like print, input, int, len, str, float, and we had also defined, we had also discussed how to define functions on our own. This is basically the how to define a function. This is the basic syntax, and this is how a function can be called. So also we discussed about the same concept actually called by two different names, that is parameter and arguments. So formally this is called the, so can someone say what is this? Is this the parameter or is this the argument? So here, while calling the function, this is the argument, and while the definition, in the definition, the items, the variables are called the parameters. But as I stated earlier, stated during the class, that these are, I mean, arguments and parameters are used interchangeably throughout. So we also discussed about recursive function and ways of avoiding them, as not ways of avoiding them, but some limitations of using this use of recursive function as well in the last class. Then we discussed about dictionary. So dictionary is nothing but again some sequence data type, but there is no order, which is indexed, but they are not indexed by some index value. It is indexed by some key, and any item which are not mutable, that is immutable items, can be used as keys. So we extensively discussed about different dictionary methods. Then we discussed about files, and I hope everyone is, I mean, as we had assignments as well as the class test, I hope everyone is okay with this file handling. Then we discussed about exceptions. Apology for my typo here. So basically, exceptions are the runtime errors which can happen due to some erroneous inputs or erroneous statements that is encountering while execution of the code. So as you have seen, that a code can work flawlessly for some output, and for some other output it can cause some error. So these are called the exceptional cases. Different types of exceptions we had seen, and to deal with exception we had discussed about this try block. We need to put the statement, the set of statements from which an exceptional case can occur inside this try block, and the corresponding handler, that is ways of handling the exceptional statement, should be put in this except block, and this finally block should be used to clean things up. Then we discussed about modules. So modules are nothing but some files containing some Python definitions or Python statements or Python classes, variables, whatever. So we kind of used some Python defined modules like math, sys, random, and we have also discussed about using some external modules like matplotlib, specifically this pyplot, which were used to plot certain data graphically in our Python output. And programmer defined modules we briefly started. I will try to do that a little bit today. So this is a module with nothing but a file, a Python file containing some statements. So this is, you can consider a Python file containing only 4 lines. The first line is irate equals to 6, second line is empty, and the third and fourth line is a function. So basically in this Python program, there is a variable and there is a function. So a module will be consisting of the same thing, a variable and function. But a module can also contain some classes as well. So some class statements can also be put inside this module as well. And together everything will be referring to them as module components. Okay, so now let's try to write some advanced modules. Okay, so let's try to write one class. Let's call it say point. The same thing I think we started discussing in the last class. So let's do the same thing. Say let's define the constructor. The constructor should be having 3 parameters: the self, the invoking object, and then 2 other parameters, the abscissa and the coordinate. So A and B. So now if I if I want to refer to the corresponding x and y component as x and y variable, then we need to have this. So if you have some question, please interrupt me. And as we have seen, to show the point, we just need to have this, and we can kind of print print, that is self dot x, and then this, and then self dot y. Okay, and if we want to use them, we just need to use some p equals to
Sir, the closing bracket would be after self.y, that string one,
which one?
middle
Oh,
one.
sorry. Extremely sorry. It should be comma. Is it correct?
Yes, sir.
Okay, then if I execute this, and we can call the corresponding show function from here as well. Show point. So if I execute this, you can see. Now if I, so let's have some, let's make it a little bit complicated. Let's define one distance function as well. Distance, it will be doing the same thing, like computing the distance between two points. Let's define one variable, say dist, which will be doing the Euclidean distance, which will be containing the Euclidean distance between 2 points. So the 2 points are x, but basically self and p. So it will be self x minus. Can someone help me write this? And then it's square, right? Then anyone? So what is the, I mean, how to do the, so basically this is the
So
Euclidean
then with
distance.
the y we will do that thing.
Yeah, exactly. So what shall we write?
Self dot y minus p dot y
Correct. Minus p
in
dot y,
that square.
then square, and then
Then the
total,
whole thing within to the power half.
whole thing to the power
Half.
half, right? And then
Yes.
we need to
Return the
return
distance.
distance. All right, so now if I execute this, again there is no immediate output. Now if I say I make it p1, sorry, and I am defining another point p2, say 10, 12, and let's print that as well. And if I execute this, you can see this. And now if I want to call this distance function, what I need to do is I need to call this p1 dot distance, and then I need to provide the corresponding p2. So you can see this will be the output. So this is the Euclidean distance between these 2 points. Okay, so now let's make it a little further complicated. So let's what to make? Okay, so let's make it say point 2D, and let's have another class, say point 3D. All right, and then we need to have the same thing here. Now the same thing. So it is in the three-dimensional plot, three-dimensional space. So what I need to provide is I need to provide this. Sorry, yeah. So I need to provide the corresponding C, the third component here as well. And to do the distance, I mean, to get the system, the distance between 2 points in the 3D, what I need to do? So I need to have the third component as well here, self dot z minus p dot z, its square. So you can see my screen, I guess. You can see my screen, right? So I'm doing the same thing here. Now let's do one thing. Let's put this in a class, in a different, not class, in a separate module. So here I am writing everything. So let's open one file. Let's call it say point. Okay, so point.py. So this is the file. I have put, I put everything here. So the code. So I saved the file here. You can see point.py. And now if I want to use this module, use this file as a module, what I need to do is I need to import that. So to import, so for example, if I just check the PWD, so you can see I am here. So now from this, and this file is also in the same path. So to import the module, that Python file from here, what I need to do is I just simply can use this import statement with only the file name, excluding the extension. So what I need to do is, so capital POINT, that is the name of the file, and if I execute this, you can see it is imported. And now if I want to do, so first of all, if I want to create, so this is one class, so there are basically two classes, these two classes are defined inside this point module. So now if I want to declare one point, so for example, if I want to do the same thing here, so what I need to do is, so I need to use that, so let's make an alias of this. So import point as p. So what I need to do is p1 equals to p dot point, and then p1 dot, so you can call it straightforward, and then again p dot point, and if I execute, sorry, oh sorry, extremely sorry, it is called, so I have made it point 2d, so that's why I need to make it point 2d, right? Still point has no point, point has a class called point 2d. So but there is a class called point2d here, so okay, then let's check it. So p dot, okay, so it is actually taking this as the point, so only it is showing that show point x and y, that is actually defined here, actually I have overwritten it. So if I just restart my kernel, I hope it will be running. Now I am again importing the point as p, and then if I execute this, you can see the output. So far I have initialized 2 points p1 and p2, and these points are objects of this class point 2d, as you can see, and this point 2d class is defined inside this module that is called point, and this is the module file. And again, if I want to check the distance between these two, I can straightforward call the distance function with these two parameters, p1, the invoking parameter, the invoking object, and p2. If I execute this, you can see this is the output. Of course, we can do the same thing using 3D as well. So to define one function, say p3 equals one point in the 3-dimensional space, what we need to do is point 3D, and then we need to provide, say, 3 components, and then say another, say p4 equals to, then again 3 components, and then if I want to compute the distance between p3 and p4, so p3 dot distance p4, if I execute this, so this is the distance between the 2 points 1, 2, 3 and 4, 5, 6 in the 3-dimensional space. Any question? Any question regarding this? So in this program, I tried to put the classes as well as modules together in a simple example. I hope it is, I mean, you are able to understand this.
Sir,
Yes.
so we need to write that program first in a file and save it, and then we are going to use it as a
Correct.
module for next one.
Right.
Okay.
So here I have, this is the file. So another thing that I want you to know is, as the PWD is same, I was able to do that. But if I put this file, say I am putting this point.py file in my home directory, okay, here I am putting the file. So you can see this point.py file is here. And if I now want to execute this, so if I again restart the kernel, then it will not be executing. Oops, no, it is executing. Why? It should not be executing. So I think I hadn't moved it. So point, oh no, I haven't moved it. So from here I am cutting it and I am pasting it here, replace. Now if I restart the kernel, and now if I try to import here, you can see module file not found, because my PWD is this, and in this path there is no file that is named as point.py. So to import, to have this, I mean to handle this kind of situation, what we need to do is we need to add the path where the corresponding file is to the class path. So to do that, what we need to do is we need to, so first of all, let's check what are the class path defined inside this Python. Sys dot path. So if I execute this, so these are the paths in which it will be looking for the module files. So now as this file is, I mean the path of this file where this point.py is actually home and then doipayon. What we need to do is to import this, what we need to do is we need to append the corresponding path here, dot append, and then if I now if I execute this, oops. Now if I execute this, you will be able to see the thing. So it is working because I have put the corresponding, so I have put the corresponding path, basically this path, inside this class path of this Python, and now it is working perfectly. So now if I, so after doing this, I mean after executing this statement, I will be able to import the file which is there in this path. Any question? So now again I will be able to execute this, I will be able to execute this, I will be able to execute this and all. Any question? So I hope we are almost done writing your own module we discussed. So where to put, we just discussed this. In general installation path, so basically the general installation paths are these. So if you just print the so these are the general installation path. You can put the corresponding module path in these paths as well, but it is a very bad, I mean, bad way of doing things. So it is better to use something like this approach. So we also discussed about classes and objects. So I hope everyone is okay with that. And that was all about CS3102. Any question? Anyone? So if you have a class, please switch to that class, but I really want you to stay for 5 more minutes if you have the time. So one thing I kind of not haven't discussed earlier, which I think Swagat was asking for quite some time, is string formatting. So let's declare some, let's try to do that. So let's declare have variables called say pi, so 3.1415654. I remember this much. And let's declare another variable called say speed, which will be the speed of light. I think it is 299792458. I think so. That much meter per second. And the string formatting is a way of formatting your output string. So to print this, the value of pi, so the way we know the things is in this way. So if I execute this is the known, we know this. So there are basically 4 other ways of doing the same thing using string formatting. So let's copy this for save some time. So another way of doing the same thing is using this placeholder. This is called placeholder. So I hope you can see my screen. So it is 1 second bracket. It basically an empty dictionary. And so now, so it is a single string. So it is a single string where there are 2 placeholders. One is this and another is this. And now what we will be doing is we will be using one function that is called format, and there we will be providing the corresponding values. So this is another way of doing the same thing. Another way of doing the same thing is using another way of this applying this formatting. So here what we can do is we can use this 0 and we can use a 1. So basically this will be considered as 0 and this will be considered as 1. If I execute, same output. The third way of doing the same thing is using one placeholder, the name. Here I am using the index, that is 0 and 1. I can use some name as well, pi p and speed of light say SOL. And now I need to define the corresponding thing. So speed of light equals to speed. So if I execute this is another way of doing the same thing. The fourth way of doing the thing is using something called which is kind of similar to C string formatting. So those of you who are kind of familiar with C will be able to understand this. So let's, for the time being, let's print only the value of pi. So to do that, what we need to do is we need to put this as pi. So if I sorry, I think I made some mistake. Incomplete format. So I think I had done some percent for. Oh, sorry. As it is a floating point, I need to put an f here. So you can see the value of pi was 3.1415654. So I have put here 0.4. So basically it will be truncated to 4 places of decimal. So although it was 1415, but as the next value is greater than 5, so basically if we truncate it, it will be 1416. That is the exact output that we are getting. So this is another way of printing a formatted string. Swagat, you were asking something regarding regarding this for a long time. So I kind of forgot this earlier. Is there any question?
Hello.
Yes, please go ahead.
Yeah, sir, actually, I missed some classes, so I wanted to know the exact schedule of the Viva, like what we are going to do. Do we need to perform the main codes? Do we need to write, or it will be?
No. So in the Viva, I will be showing you some codes, or you don't need to write any code during the Viva. So maybe
Okay.
I'll be providing some small code snippets, and I'll be asking you to, say what will be the output, or is there an error, something like that.
Okay,
Or
okay.
I'll
And sir,
be.
how long will it take? Because I have another test also.
So
So
when is your exam? When is your this test is scheduled? This Viva.
at 2 p.m.
Which day? I think
1st
Monday,
December.
right?
Yeah,
Oh, first, that is Tuesday.
Tuesday. Yeah.
Okay. So I don't think it will take more than 30 minutes.
Oh, okay, okay.
So that, but I had given a time period of 45 minutes window. There will be a window of maximum, I think, 15 minutes in between two tests.
Okay.
No, any question regarding this? Regarding the things that we have discussed in this course altogether, or this string formatting? So if everyone is okay with that, so thank you so much. So I hope you learned something from out of this course. Yeah, Ishita, I think, no, Ishita or Ronak? Ronak raised hand. Yes, Ronak, can you please, you want to ask something? Or you have asked something in the chat? No? The keywords involved in I didn't get the question. The keywords involved in exception handling. Oh, the keywords are try, except, and finally. So they are actually there in this list, right? So if I go through this, I think, where was the list? Yeah. So try, I think it is there. Try, then except, I think E. Oh, I forgot to put it here. Except is, oh, except is here, and finally FF finally. So they are there. Yeah. So do you have any particular question regarding this, Ronak? Yeah, I don't know. What does finally mean? We discussed this earlier. So finally is just for, I mean, the main purpose of using finally in your class definition, in your exception handling is to clean things up. So while discussing, we had discussed, I mean, while discussing about the right way of, opening a file and closing a file. So if you are with me, let's open that file. I think it was this. So here, finally, here, so in this example, it is, although it is not actually the file handling thing. So this finally statement will be executed if there is no exception. Also, if there is some exception, it will be getting executed. But there is some, there is a difference between this finally cleaning and all went smoothly. There is a difference if there is some exception that is not handled. This statement all went smoothly will not be getting printed. So try will be raising the corresponding exception, and if the exception is not handled, it will be returning the exception to the invoking Python interpreter of your operating system, and it will be closing its execution at that point, and this statement will never execute. But this finally will be executing in any case. I mean, if there is some exception, also, in case of, at every cases, this finally statement will be executed. I discussed with an example. Let's try to open that example. So is this example well enough, Ronak? I can put this, I can try this. Are you there? I can see Ronak there. Okay, so I hope it is okay, right? I mean, the confusion is clear. The use of finally. Okay, is there any further question?